Hello everyone! Welcome to the video tutorial on the derivation of cosine difference and some identities. Let's start. Let's begin by this circle. We are going to call the origin as point O and this point here as point P, and it has an ordered pair 1 and 0 because a distance from the origin in a unit circle is 1, and we have drawn an angle here which we will call as angle P, and it gives us an ordered pair, and we are going to call this point as Q, and its ordered pair is cosine B and sine B. From the definition of trigonometry functions, that cosine B is equal to x and sine B is equal to y. Now we have the second angle here, which we are going to call as angle A, and it gives us a point, and we are going to call that point as point S. And its ordered pair is cosine A and sine A, still from the definition of trigonometry functions. Now we're off to the next angle. All of this is angle A, then subtract off whatever B was, and we have a new angle form which we are going to call as A minus B. And that will give you another point on the unit circle which we are going to call R, and its ordered pair are cosine A minus B and sine A minus B. In addition though, what if we said all of this angle A, but instead of taking B off of this way, let's take off B from the axis. We take this off, and this angle SOQ, you see this angle? From this angle A, you take off B from here, and this new angle form. What are you going to call this? So this angle is also A minus B. Now we have the same angle. Alright, so the points we have here in this circle can make what we call chords. There is a chord from point R to point P. This chord right here is the chord RP, and it is the opposite from the angle A minus B. So we have another chord, not only the chord RP, but we also have the chord SQ. It is from the point S to point Q. These chords RP and SQ has a certain distances. Well then, those two distances, the two chords RP and SQ, have to be the same length. So then we know that chord RP is equal to chord SQ. So then we know that chord RP is equal to chord SQ. So we will use the distance formula for the both of the chords, and this is the result. Cosine A minus B minus 1 squared. So cosine quantity of A minus B is from the value x value of R, and 1 is the x value of P squared from the distance formula, plus sine quantity of A minus B minus 0. So sine A minus B is from the y value of the R, and 0 is from the y value of P, is equal to cosine A minus cosine B squared. So cosine A is the x value of S, and cosine B is the x value of Q, plus sine A minus sine B squared. Sine A is the y value of S, and sine B is the y value of Q. Next is we are going to simplify these two. So cosine quantity of A minus B minus 1 squared is equal to cosine squared quantity of A minus B minus 2 cosine quantity of A minus B plus 1. Sine quantity of A minus B minus 0 squared is equal to sine squared quantity of A minus B. Here, cosine A minus cosine B squared is equal to cosine squared A minus 2 cosine A cosine B plus cosine squared B, and sine A minus sine B squared is equal to sine squared A minus 2 sine A sine B plus sine squared B. So this is the result if you squared the two. Now, we will do some combining of terms. So, cosine squared a minus b plus sine squared a minus b is just equal to 1. Because according to Pythagorean identity, cosine squared theta plus sine squared theta is equal to 1. So, we've got another one here. So, 1 plus 1 is equal to 2. And copy this. So, 2 minus 2 cosine quantity of a minus b. And we also have it here, cosine squared a plus sine squared a is equal to 1, and cosine squared b plus sine squared b is also equal to 1. So we've got 1 plus 1 equals 2. And copy this leftovers. So 2 minus 2 cosine a cosine b minus 2 sine a sine b. At this point, we can subtract 2 from both sides and we can divide negative 2 from both sides, so we can get cosine quantity of a minus b is equal to cosine a cosine b plus sine a sine b. So this is now the cosine difference identity. So now that we get the cosine difference identity, we will now move to cosine sum identity. We already know that cosine quantity of a plus b is equal to cosine quantity of a minus quantity of negative b. We will use the cosine difference identity to get the cosine sum identity. So from here, we get that negative b is now our second angle. So all you have to do now is substitute the negative b or second angle to the cosine difference identity. So the result is cosine a cosine of negative b plus sine a and sine of negative b. With that, this leads to cosine a and cosine of negative b. Recall that cosine is an even function, so cosine of negative b is equal to cosine b, and sine is an odd function, so sine of negative b is the same as negative sine b. So now this will change to minus. So minus sine a sine b. So the cosine sum identity is equal to cosine a cosine b minus sine a sine b. This is the end of my video tutorial. Hope you learned something about the derivation of cosine difference and sum identities.